Here's problem 1. It says Ann, Bob, Chad, and Dave are all contestants on the game show Hickam. 3 of the contestants will be picked to move on to the next round, while 1 has to go home. Using the letters of each person's name, list out the possible combinations of people who would be moving on to the next round. Order doesn't matter. Thus, when you list them, put them in alphabetical order. So we have, I'm just going to use A, B, C, D for their names. Ann, Bob, Chad, and Dave. So only 3 of them go on. So maybe Ann goes on, Bob goes on, and Chad goes on. We'll leave Dave at home. Or maybe Ann goes on, Bob goes on, and Dave, this time Chad stays at home. Or maybe we could leave Bob at home. Ann goes on, Chad goes on, and Dave goes on. We've exhausted the list for Ann going on. So notice that what happens, because again, we're not going to list ABC is the same as CAB, because we're just listing 3 people. Here, order does not matter. ABC is the same thing as CBA, is the same as BAC, is the same as ACB. So that whole idea of permutations we did earlier doesn't matter here. This is a combinations problem where order does not matter. So I've listed these out. Now I could deal with one more situation where I don't have Ann going, but I have Bob going on, Chad going on, and Dave. So that'd be Bob, Chad, and Dave. Notice there's no more possibilities. Where normally when we dealt with this in a permutations, there would have been 24 different ways to put these people in order. Here, it's not that way, because the reason being is that, like I said earlier, Ann, Bob, Chad is the same here as Bob, Chad, Ann, or Ann, Chad, Bob, or Chad, and Bob. All those are the exact same, so we don't count them over and over and over again here, because we're just moving 3 on. So the answer, here's your listing of the people. There's only 4 possibilities of 3 of these people moving on in this contest of Hickamania.